Good morning, everyone. My name is Dr. Rama. I am working as an assistant professor in Marri Laxman Reddy Institute of Technology and Management. Today, I am going to discuss about the subject remote sensing and GIS. And today, I am going to give you the lecture of photogrammetry in remote sensing and GIS. So, coming to the course objectives and course outcomes. This course will make the student to understand about the principles of GIS and remote sensing and spatial systems and its application to engineering problems. And the course outcomes are, at the end of the course, the student will be able to understand retrieve the information content of the remotely sensed data, analyze the energy interactions in the atmosphere and Earth surface features, interpret the images for the preparation of thematic maps and apply the problem-specific remote sensing data for engineering applications, analyze the spatial and attribute data for solving various spatial problems, and create the GIS and cartographic outputs for the presentation. So this is the syllabus in remote sensing and GIS subject. So the unit 1 is the introduction to photogrammetry and what are the various principles and types of various aerial photographs, what are the various types of terrestrial photographs, what is the scale and height measurement on a single vertical aerial photograph, what is the height measurement based on the relief displacement, and what is stereoscopy, what is the fundamentals of stereoscopy, what is the fiducial point, what is the parallax, what is the stereoscopy analysis, and how to measure the parallax theory. This is all the things we are going to discuss in the first unit. Coming to the remote sensing, which is unit 2, the basic concepts of remote sensing, what is the data and information, what is the EMR, electromagnetic spectrum, etc. All the topics we will discuss in the unit 2. Coming to the unit 3, GIS, Geographical Information Systems. What is the introduction to GIS? What are various components of GIS? What is spatial data input? What is the attribute data management? What is the data display? What is the data exploration? What is the coordinate system? What is the geographic coordinate system? Approximation of the Earth, datum, etc. All the things we are going to discuss in unit 3. Coming to the unit 4, in vector data model. So what is the representation of various simple features like topography, topology, and its importance? What is the coverage and the data structure? What is the based vector data model, the geo-based database model, and what is the geometrical representation of spatial features and data structure, etc. All the things which lie in the 4th unit, that is vector data model. Coming to the last unit, that is 5th unit, raster data model. So what are the various elements of raster data model? What are the types of raster data? What is the data conversion? What is the integration of raster and vector data model? How to integrate the raster data and the vector data? And what is the data input, metadata, etc. All the things we will discuss in the 5th unit, that is the last unit. So today we will discuss about the first unit, that is photogrammetry. So photogrammetry, it is basically a Greek word. Photo means light, gramma means to draw or to measure, metron means to measure. So this is all the meaning of the photogrammetry. That means with the help of the light, how to collect or how to withdraw various measurements like what is the distance, what is the area, what is the various elevation of the building, what is the distance between the two structures, what is the distance between two buildings, what is the size and shape and orientation of the building, what is the area of any project we have to cover. That means if we would like to discuss or we would like to cover an area, so what is the area of that particular feature or site, or what is the elevation of the building, what is the height of the structure, what is the size of the building, what is the shape of the building, what is the orientation of the building. So this is all the kind of information, or this is all the kind of measurements we will withdraw or we will collect with the help of the light. So that is called photogrammetry. So basically photogrammetry is with the help of the light we will draw or we will collect the various measurements like distance, area, elevation, size, shape, orientation of the building. So these are the collective measurements we will take with the help of the light. So that is the real meaning of photogrammetry. So coming to the definition of the photogrammetry, it is art, science and technology of obtaining information about any physical objects and carrying out various measurements from the air photographs. That means, so if you see the beside photograph, so this is the aeroplane which is mounting the camera inside it, so facing the downward direction. So this is the vertical photograph which has taken from the air. That means this aeroplane is mounting the camera which is facing the downward direction, and this is the vertical photograph which has taken from the aeroplane of any city or any area we would like to capture or would like to measure the measurements. So this is the art, science and technology of obtaining any information about the physical structures like buildings or any beach or any structures or any object, and identifying the objects or the collecting the various measurements like distance, area between any two features or any two structures, what is the shape of the building, how many stories in that particular building, so etc. All the information we would like to capture or we would like to measure from the various vertical aerial photographs. So this is all the basic principle behind the photogrammetry. So today photogrammetry is heavily dependent on software and hardware. So if we see, as we all know, earlier days there were no soft copies, only there were hard copies. That means if you go to any survey of India or NRSC, National Remote Sensing Center, so there will be available of some topo sheets or some hard copies of thematic maps of any particular area. So in those topological sheets or topographical maps, you can see the various features like rivers, canals, parks, recreational centers like cinema halls, commercial complexes, hospitals, forest area, greenery area, water bodies area. So every information, the topological map, that is hard copy, containing those all kind of information. But nowadays everything come under the digital format, so there is no need of any hard copies. Everything is nowadays soft copy. So photogrammetry is basically are heavily dependent on software nowadays, but earlier days there was only graphical photogrammetry, analytical photogrammetry, analogical photogrammetry, which comes under only in the format of digital, or which comes in the format of hard copies only. But nowadays everything is the software format, everything is the digital format. So photogrammetry requires certain skills and judgments to interpret the data, to analyze the data. So the normal people like you and me cannot analyze or cannot interpret the data from the photogrammetry or from the photographs which has taken from the air. So there will be some experts, there will be some experienced interpreters to understand the data, to interpret the data, to analyze the data which were captured from the air. So photogrammetry requires certain skills and judgments to understand or interpret the data. So what a photogrammetry can do? So with the help of a single vertical photograph, the distance between two objects or distance between two buildings or distance between two structures, so those kind of information we can get from the single vertical photograph. Object height or length, any one parameter can decide from the single vertical photograph. Area and perimeter of the polygon. So if you would like to capture or we would like to execute any project, if you would like to construct any building in an area, so what is the area of that particular site, what is the area of that particular building, so etc. All the data we can analyze from the single vertical photograph, and mapping also can be done with the help of single vertical photograph. But with the help of a stereoscopic aerial photograph. So what is the difference between single vertical photograph and stereoscopic vertical photograph? Single vertical photograph means it is taken in a single manner, but whereas stereoscopic aerial photograph means two or three photographs, because one photograph is not sufficient to cover the entire area. So then we would have to capture two or three photographs or 5 to 6 photographs to capture or to cover the entire area, and we would like to overlap those all 5 to 6 photographs to take any measurements or to collect any measurements. So those are called stereoscopic vertical photographs. That means 2 or 3 photographs or 5 or 6 photographs are taking, and overlapping region will be used to collect the measurements, to analyze the measurements. That is called stereoscopic vertical photograph. So with the help of stereoscopic vertical photograph, we can identify the location of the building and streets or poles, canal, pond, etc. And we can also analyze the object height. What is the height of the building? What is the height of the structure? What is the elevation of the structure? And 3D model also we can do with the help of a stereoscopic vertical photograph, which is not possible in case of single vertical photograph, because in single vertical photograph there is no need of three-dimensional space, but here with the help of stereoscopic aerial photography only the three-dimensional model can be developed. So the best example for the three-dimensional model is digital elevation model, DEM. So this is the example for 3D model. So with the help of stereoscopic vertical photograph only, the three-dimensional model can be developed, but which cannot be developed with the help of the single vertical photograph. So in stereoscopic vertical photograph, there are three-dimensional x-axis, y-axis, and z-axis. So 3 axes will be present in the help of in the case of single vertical stereoscopic aerial photograph. But whereas the single vertical photograph, there are no 3 axes present in the single vertical photograph. So measurement on 2D or 3D images. So photogrammetry is the technique of measuring ground objects from the photographs in two-dimensional or three-dimensional environment. So to obtain high accuracy, aerial photographs must be of the highest quality. That means the photographs which are captured from the air should depict the highest quality and should be more accurate to analyze that particular object. So if we would like to capture or we would like to identify any objects on that particular ground, those images or those photographs which are captured from the sky, which are captured from the air, should depict the highest quality and should be more accurate like this. So then only the analysis of the ground objects or any collective measurements we would like to carry out can be possible if the photographs are of highest quality and should depict the highest quality. So coming to the history of the aerial photogrammetry, in 1858, Gaspar Felix, he was the first person which captured the aerial photograph, or that means vertical photograph from the hot air balloon. Because of the instability of the hot air balloon, because with the air movements, the balloon will be moved here and there. So with the instability of the balloon, he couldn't able to capture the exact vertical photograph. So this is the vertical photograph he has captured from the hot air balloon. So a basket was hanged beneath the balloon and he was holding the camera, and with the help of a camera he was captured the exact vertical photograph. But because of the instability of the balloon, because of the instability of the hot air balloon, the exact vertical photograph was not possible. So it has come like this. So with the help of this vertical photograph, we can able to identify the how many stories in that particular building, what is the size of the building, what is the shape of the building, what is the orientation of the building. So this is the kind of information we could analyze with the help of this kind of photograph. So in 1860, James Black photographed one of the other area, that means US. He also captured the vertical photograph from the hot air balloon only, but he is also not the exact truly vertical photograph, because we could see there is a little bit of inclination or tilting which has present in this particular photograph. So in 1987, Alfred Nobel, because he was the first person who has captured the exact truly vertical photograph. So based on his name only, the Nobel Prize has come into existence. So he is best known nowadays for the Nobel Prize. So he has captured the exact truly vertical photograph from the rocket itself. So in 1903, Julius Neubrenner designed a tiny mounted camera which has installed in the pest of the pigeons. So we all know the pigeons are very friendly, so they will come back. So Neubrenner has designed some tiny camera and he installed in the pest of the pigeons, so to capture various vertical photograph. And some persons has also used the kites to capture the exact vertical photographs before the invention of the aeroplanes. So after the invention of aeroplanes, various aircrafts used in the photogrammetry to capture the exact vertical aerial photographs. So these are some kind of aeroplanes which has used for the capturing of various vertical images. So you can see a person has to stand in the aeroplane holding the bulky cameras to take the photographs. But nowadays there is no need of any manpower to capture the images. Even if we want to shoot in a wedding, so the drone can manage the entire wedding, so there is no need of any manpower nowadays. But earlier days, a man has to stand, a man has to hold with the bulky camera set up with this like this, and he is going to capture the images from the sky itself. So coming to the technological developments in the photogrammetry. So earlier days there was a graphical photogrammetry, and after that analog photogrammetry and analytical photogrammetry, and nowadays everything is comes under digital photogrammetry. So in graphical, analog and analytical, there will be only hard copies format available. But coming to the digital format, there is no need of any hard copies, everything is soft copy. Even nowadays, if we would like to know any information about any object or any area, so you can get the information from the Google Earth itself. But earlier days there was no such kind of technology, so everything was under the hard copy format. So coming to the types of photogrammetry, there are two branches of photogrammetry. One is aerial photogrammetry and one is the terrestrial photogrammetry. So what is the difference between aerial photogrammetry and terrestrial photogrammetry? So if the photograph is taken in the vertical direction, that means from the top of the air, it is called the aerial photograph. Coming to the terrestrial photograph, when the photograph is taken in the horizontal direction, that means the camera setup is mounted on a tripod camera, or a man with the camera holding and standing in the ground itself. So that is called the terrestrial photogrammetry. So basically the difference is the aerial photogrammetry, every photograph will be taken in the vertical direction. In the terrestrial photogrammetry, every photograph will be taken in the horizontal direction. So with the help of the vertical aerial photogrammetry, we can analyze the height of the building, we can analyze how many stories in the particular building, or it can be used for any mapping purpose or for engineering survey purpose, etc. But whereas the terrestrial photogrammetry will be helpful to identify the monitoring of the structure, very close monitoring of the structure, any deflection studies or deformation studies to identify any cracks in the buildings. So the horizontal or terrestrial photogrammetry will be helpful for those kind of purposes, because with the help of vertical photogrammetry, the cracks will not be appear from the top view. So with the horizontal photogrammetry only or terrestrial photogrammetry only, we can observe or we can monitor the buildings in a very close manner, in a very close angle, so that we can identify or we can analyze any deformations in that particular building, or any reflections in that particular building, or any facade mapping. That means we can have the face of the structure. So we can do the facade mapping also with the help of terrestrial photogrammetry. So basically there are two branches of photogrammetry. One is aerial photogrammetry and one is terrestrial photogrammetry. So this is all for today's lecture. Thank you.